Hello everyone and welcome back to the channel. We have taken up a question of exercise 6.3 question 24, which is based on maximum minimum. Another question 23rd was taken up in the next video. I'll share the link in the description below. So let's take our books and pen and start with the question. So here the question is, show that the right circular cone of least curved surface and given volume. So let's start with the volume. This part will come to on and later, which says we have to prove that the altitude is equal to root 2 times base. So first let's find, because volume is given, let's start with the volume of the cone, which is 1 by 3 pi r square h, and these are the regular notations. R is the radius and h is the altitude. Okay. Now from here we have to decide whether we will find r or h to substitute in the CSA. So what is the surface area of the cone? Pi r L. Now here there is L and R, here there is R and H. So let's convert L to H and R, that is using the formula of L. From here, if we find R, we will have to substitute in two places. Also, we will have to write it in terms of root. So, it's better to find H. So, we will be substituting H is 3V upon pi r square. So, squaring here, we have 9V square pi square r raised to 4 plus r square. So, this is our CSA. You can take this as your function or you can take the square of this, because whatever critical points we get with the square will be the same which you get with this function, and solving the square is easier. So I am going to square this and take this as a function. Simplification will give us our equation to be 9V square upon r square plus pi square r raised to 4. This is our equation or the function. Now as we know, in order to find maximum and minimum, we need to first find the derivative of the function. So we are going to find f dash r. So differentiate this. 9V square is constant, derivative of r raised to minus 2, that is minus 2r raised to minus 3. So 9V square upon r square, when differentiated, will become 9V square constant and this derivative, which is minus 18V square upon r cube. So the derivative of the first term is minus 18V square upon r cube. Let's put that. And the derivative of r raised to 4 is very easy. It is 4r cube. This is the first derivative. Again, to look for least value, you need to first find the critical point. So let's equate it to 0. So we have, it is 18V square upon 4 pi square, which is r raised to 6. Or rather we can write this as, so value of r is 9V square upon 2 pi square raised to 1 by 6. This is our critical point. So we need to look that at this point, are we going to get maximum or minimum? So we will have to find f double dash r. Since we are using the second derivative test, those are the standard steps. First find f of r, then f dash r. For critical point, equate f dash r to 0. Now find f double dash r. So it's differentiating the third equation. So as we did for r raised to 2 in the denominator, same way we will do for r cube, and we have minus 18V square into minus 3 upon r raised to 4 plus 12 pi square r square. Now this is positive, this term is also positive. Overall f double dash r is greater than 0. Therefore f of r is minimum when r is 9V square, and that is at the critical point, when r is 9V square upon 2 pi square raised to 1 by 6. At that value, function will be minimum. Now R function was the square of CSA, so the CSA will also be minimum, or the CSA is least at this value. That's the first part. Now what else we want to prove? We want to prove that the altitude is root 2 times the radius. So to find this, let's again start with a critical point with this, or rather with this one. So we can take 18v square upon 4 pi square is equal to r raised to 6. You can also start with the first equation where we had started with the volume and substitute the value of r over there, but it's most of the cases it's easier to start with the critical point. So put v value here now, which is after squaring so we have h square is 2r square, or we can say h is root 2r. The altitude is root 2 times the radius, and that proves with the question. Hope you understood the question. So if you are interested in questions like this, if you think someone will be benefited, then please do share the link. Also do subscribe to the channel, and see you soon. Thank you.